This video is about solving quadratic equations, specifically using the method of the square root property and completing the square. When we solve a quadratic using the square root property, we want to make sure that our squared piece is isolated. So that may be just an x squared term, but it may also be an expression that is squared. Something, for example, like 3x plus 2 quantity squared. We want to make sure that our squared piece is isolated, and then we'll take the square root of each side. The important part about taking the square root of each side of an equation is that when you put a square root into the equation, you have to take both the positive and the negative square root. So when we have a quadratic equation with something squared but no specific x term, then it's pretty straightforward and a good practice to use the square root property. So I've got 3 examples down here. So for example, in this particular case, we have an x squared, and we want that x squared to be by itself. So we're going to add 32 to each side, and we get x squared equals 32. Once I have my squared piece isolated, I'm going to take the square root of each side. Now I'm going to do that in a different color. And make sure that you're taking both the positive and the negative square root on the right-hand side. So the square root of x squared is just x. On the right-hand side, we get the square root of 32, which is not a perfect square, but it does have a perfect square factor of 16. And then we simplify, keeping that plus or minus. The square root of 16 is 4, and square root of 2 can't be simplified, so we get plus or minus 4 square root of 2. So we actually get 2 answers. It is a quadratic, and we get 2 answers there. For our next example, we don't just have an x squared, but we have a binomial that's squared. And it really doesn't matter if it's a binomial or a trinomial, but we've isolated the squared piece. So when we take the square root of each side, I'm going to write that down here. We're going to get the positive or negative square root of 17. Then simplifying, when we take the square root of something squared, we just get that something, plus or minus root 17. And then adding 4 to each side, we get 4 plus or minus root 17. And in this case, root 17 cannot be simplified. But again, we do have 2 answers. We really have 4 plus root 17 and 4 minus root 17. So make sure that you're using that plus or minus so you get all of your solutions. For part C, in a similar way, so if you've watched the previous video about solving quadratics using factoring, when you're factoring, you use the zero product rule and you want it equal to 0. But when we're doing completing the square, that may not be the case. We just want this squared piece to be by itself. So in this case, I am going to subtract 5 from each side of this equation. So I have my squared piece isolated, and then I'm going to take the square root of each side, remembering that when I put it in, I need the plus or minus. So we're going to get 4x minus 2 equals plus or minus root negative 5. So keep in mind that when you're taking the square root of a negative, that negative sign comes out as an I. So we're going to get plus or minus I root 5 on the right. And then we're going to simplify by solving for x. So we will add 2 So we'll get 2 plus or minus I root 5. And then we will divide by 4. And we will get x equals 2 plus or minus I root 5 all over 4. So again, we get two answers here. We get 2 plus I root 5 over 4 and 2 minus I root 5 over 4. So this kind of leads us to another way that we can solve a quadratic. In these examples, I had my squared piece all ready to go. And for part B and part C, one option would have been to multiply out the binomial and try to factor or use another method. But one of the methods that we use is called completing the square. And basically, for completing the square, we want to be able to create that situation where we have that squared term all ready to go. So I'm going to start with this first example. Notice that this does not factor. We usually try to factor first. Nothing multiplies to 19 except 1 and 19, so it's not going to factor. But I would like to use the method of completing the square. So this is what we're going to do. We're going to isolate the constant on the right side. I'm just going to move it over. So in this case, we're going to have x squared minus 6x equals, we're adding 19 to each side, 19. Now you'll notice I left a little space here. And I'm going to put a little space over here as well, because I want to add something to both sides of this equation so that I have a perfect square trinomial on the left. So the next step is to add 1/2 the middle term squared. So just the constant, or just the coefficient, excuse me. So here we have a -6. Of course, -6, half of that is -3. And if we square that, we get 9. So we're going to add 9 to this side, which requires us to add 9 to this side. We're almost done. On the right-hand side, 19 plus 9 is going to give us 28. On the left-hand side, we just completed, or we just made this into a perfect square trinomial. And if we factor it, we're going to get x minus 3 quantity squared. So don't think too hard on this. This half of the middle term in this case was -3. And that's why we have a -3 here. Now I'm going to take the square root of each side, plus or minus, and I'm going to simplify. So we get x minus 3 equals plus or minus root 28. 28's not a perfect square, but it does have a perfect square factor of 4. So we're going to simplify that, plus or minus 2 root 7, and then we will add 3 to both sides. So 3 plus or minus 2 root 7. So the idea is that we make the left-hand side a perfect square trinomial, and then we use the square root property. So let's do that again for this next example. Solve by completing the square. X squared minus 5x plus 1 equals 0. Now, I kind of threw this one in here on purpose because you'll notice that our middle term is not even. It's actually odd, but that's okay. I know you don't love fractions, but that's okay. We're going to isolate the constant to the right. So we're going to get x squared minus 5x, we'll leave our space here, equals -1, and then we'll put a space here. So what are we going to add? We're going to take half of -5, which is -5/2, and then we're going to square -5/2 and get 25/4. So we're going to add 25/4 to each side of this equation. So we took half the middle term, that was this, and then we're going to take half the middle and we're going to square it. So if I factor this left-hand side, remember it's a perfect square trinomial, and half of the middle was -5/2, I get x minus 5/2 quantity squared. I'm going to write my -1 as -4/4. And we have x minus 5/2 squared equaling 21/4. And at this point we use our square root property. So we take the square root of each piece, remembering to take the plus or minus, and we get x minus 5/2 equals plus or minus root 21 over the square root of 4, which is 2. And then we add 5/2. So we get 5/2 plus or minus root 21/2, which is fine. If you want to, because these have the same denominator, you can combine them and write 5 plus or minus root 21 all over 2. I do have one more completing the square problem. This one is slightly different. We'll do 3x squared minus 6x plus 11 equals 0. The reason that this one is different is you'll notice that our coefficient of our squared term is not 1. So what we're going to do here is divide everything by 3, because I need that to be a positive, just 1x squared. So I'm going to divide everything here by 3, and I'll get x squared minus 2x, and I'm going to move this over to the other side and get -11/3. So I need this to be a 1x squared. When I complete the square now, I take half of the middle term. Half of the middle in this case is -1. And the half of the middle term squared is -1 times -1, or just +1. So we're going to add 1 to each side. And then we're going to factor. So I'm going to rewrite this as x minus 1 quantity squared, because remember it's always the half before you square it. And I'm going to write this as -11/3 plus 3/3. At this point, let's add the right-hand side. We'll get x minus 1 squared minus 11 plus 3 is -8/3. And then we'll use the square root property and take the square root of each side, remembering to take that positive or negative. And oops, that was weird. We're going to get x minus 1 equals plus or minus. Let's go ahead and take that negative out. I root 8 over 3. And 8's not a perfect square, but it does have a perfect square factor, so I'm going to write it as 4 times 2. And let's simplify that right-hand side. So we're going to get plus or minus. We'll bring this square root of 4 out and get 2I root 2 all over 3. And then we'll add our 1. Now the 1 is not divided by the 3, so remember that. But if you wanted to, you could make this 3 over 3, and then you could write it as 3 plus or minus 2I root 2 all over 3. That concludes this video. See you next time. I do have one more completing the square problem.